So let alpha denote Zj hat star. What we've shown so far is that the probability that this clause Cj is satisfied is at least 1 minus 1 minus alpha over k to the k. Now once again, we want to get this alpha outside of this power. We want to make it a linear function of alpha. So let's look at this function of alpha. Let's define f of alpha to be this right-hand side. And our claim is that f of alpha, so this right-hand side here, is at least some constant times alpha. Now it's a constant in the sense it's independent of alpha. It does depend on k, the size of this clause. Now what is that constant there? Well, it's going to be similar to this without the alpha. It's going to be 1 minus quantity 1 minus 1 over k raised to the kth power. Once we prove that, then we can apply that here, and we get that this is at least this quantity, which is this constant, times alpha. So we got the alpha outside of the power. So it's now linear in alpha. It's linear in this z. Now how do we prove this claim? Well, first off, you take the second derivative and you prove that it's negative. Therefore, this function is concave. Now, since f of alpha is a concave function, it's going to look something like this. Now we're trying to relate f of alpha, this curve, to this linear function. Let's denote this linear function as beta alpha. So this quantity here is beta. Now let's look at this line beta alpha. Now for large values of alpha, it might not be bigger. But notice, what values of alpha are we interested in? We're interested in alphas between 0 and 1. So we only need this claim for values of alpha between 0 and 1. So since it's a concave function, it's got one peak. So if we look at the endpoints that we're interested in, 1 and 0, and if we prove that this curve is above this line at these 2 points, 0 and 1, then it's also above at every intermediate point. So once we take the second derivative and prove it's concave, then it suffices to check the point 0, alpha equals 0, and alpha equals 1. And if you plug in alpha equals 0, we get 0 on both sides, and alpha equals 1, it's straightforward to check that that's also true.